Okay. Yeah, so volume sounds good. We are here today, January 22nd. I'll just up front, I'll say last lecture I forgot to post right away, but I posted it this morning. I guess I just got distracted with something else. So if you're looking for the video, it's up now. Um, we are here. So this weekend, tutorial 2 is due and assignment 1. So make sure you get both of those things in. Tutorial 2 is technically due Saturday at midnight. The server, though, does not shut down automatically. I have to wake up and turn it off. So probably sometime Sunday morning, I will take it down. So I would say, you have probably till about 8 a.m. And then assignment 1 is also technically due Sunday at midnight. If you look at the bright space, I believe it stays open until 8 a.m., right? So in this class, if you manage to submit something, it's not considered late, okay? So as long as you submit it, it might tell you that it's late, but as long as you get it in there, it's not late. Once the server closes, then it's late, right? And then again, if you like just miss the server deadline, you're working to the wee hours of the morning for whatever reason, email me your completed assignment as soon as possible. The closer to the deadline it is, the more likely it is that we can accept it. If it's too far from the deadline, then it's just 0. Essentially, we don't want to disrupt the marking of the TAs. For test 1, or for assignment 1, the test suite is fine, right? So that's going to give you 30 marks. And then the other 10 will be a TA. Why is this? It's really booming today. So yeah, generally speaking, we don't, unless you've done something like use the vector, right? So you're not allowed to use vectors or the standard template library. So if you've done something that is, you do not have express, you were not given permission to do, basically, and the sort of the rule of thumb is that if you've made your life easier, you probably shouldn't have done that. If you've done something that's we did not explicitly give you permission for, but it's actually as technically challenging as what we're doing or more, then that's probably fine. Right, so that's the general rule of thumb. We do want you to sort of bump your head into certain problems and then fix them so that you learn what these problems are. Yeah, so that's it or that's the agenda as far as the tutorials and assignments. Test 1 is next week. It's a week from today. And what a mess. I got to say, when I fill out the feedback form, it may not be 5 stars for this COMAS thing. But hopefully it's resolved today. So there is issues with who is supposed to approve it, I suppose. And I don't know, it's all above my head. Yeah, the practice test. Well, here's the thing. So if the COMAS issue is not resolved today, we're going to pivot to paper. So I still don't know for sure what the test is going to look like. So the practice test will also be different. So today we're going to find out once and for all what we're doing next week. Fingers crossed. I mean, if I don't get answers, we'll just go with a paper test, which is not, not what I had hoped for, but at least it's something. So yeah, I do have a practice quiz if it's paper, and I have a practice quiz if it's COMAS. So I hope to release one of those today. If it's paper, though, it might be till tomorrow because I might have to go through and I don't know, assemble some sort of new test material. If it's on paper too, there might be some multiple choice instead of just programming. Because all written programming might be like, well, it's a mess to mark, really. That's the reason. Anyway, questions? Okay, so yes, sorry for the delay on the final decision, but some of this stuff is out of my hands, so hopefully today. Last class, we were talking about constructors and destructors. right? So constructors are, of course, they're a way to, basically your class is, it's basically a struct, right? Except, it has some functions associated with it, but otherwise, like when you look at it in memory, it is a struct. It's just a bunch of variables pushed together in memory, or a bunch of data types. And so, one of the problems from C is that people forget to initialize these things, and then you have things like dangling pointers or old data in these structs that, and then when you run it in debug mode, those are automatically zeroed, and when you run it in production mode, then they no longer get zeroed, and then you have these bugs. So the answer to that is constructors, which is every time I make an object, some constructor is called, and that constructor should initialize all the member variables. All right, so we saw we can make multiple constructors, right, with any number of parameters we like, or we could have like one constructor and then have default parameters. And those default parameters mean that I can call the destructor with no arguments if I like, or the constructor, and then it'll, that'll work. And then we looked at destructors, and right now destructors don't do anything, so they will when we get to the next section on memory management. But for now, we just wanted to see when they run. And so when I make a class, of course, I get a destructor for free, which means basically that my object can be destroyed. But I can override that and I can make it and do things like some explicit, cleanup of resources, save files, delete memory, things like that. But for now, we just wanted to see where they run, and that gave us an indication of when it gets called, right? It gets called implicitly. Now, it is a function. You can call it explicitly. That's not really recommended because at the end of the, if you call the destructor, right, and assume your object is destroyed, the problem is the memory is not reclaimed, right? So you want the memory reclaimed also, which means that you want to wait till it's called implicitly. And when it's called implicitly, the memory is also free. And we saw that basically when we statically allocate objects, basically they're destroyed when their context is destroyed. So if I allocate an object on in a function call, then in that stack frame, there will be some memory reserved for that object. When that stack frame is popped off, the destructor is called, and the memory is like reclaimed, which means that, well, I don't actually have to release stack memory, right? It's just a pointer, and I just overwrite it later. So that's where we left off. And that brought us up to copy constructors. So copy constructors are sort of like a C++ specialty. Copying things is not really a big deal in Java, but in C++, when you do something, kind of the default behavior is to make copies of things, right? Because copies are safer than passing around a reference to an object, right? So if I have multiple things referencing an object, well, if those things are in different threads, then I have race conditions, and if one thing deletes that or changes it, then the other thing that references it might not, that might cause a bug there. So making copies is like safe by default. And we make a lot of them, but we want to make sure that they're done correctly. So we're gonna look at the copy constructors. Now, when I make a copy constructor, those are the two function. Sometimes just a word like leaves your head. Those are the two function prototypes. That's it. All right. So if I want to make a copy constructor for a date class, I'm going to pass in a date by reference. And the other choice I have is to pass in a const reference, which we will take when we get to encapsulation. But for now, we're going to be focusing on this version. Incidentally, you do have a copy constructor in every class you make by default. And the copy constructor that you get by default looks like the second one here. You have to submit it to Brightspace, yes. So that's a very good question. Assignment 1, please submit to Brightspace. There's no link on the server to submit it. So yeah, just I guess sort of if we if you were using a Mac for assignment 1 and you were compiling natively rather than using parallels or something, then there was a bug in the date class because I had left, for whatever reason, I left a copy constructor in there. And I left the copy constructor that looked like this. And there are certain operations that you can't do that on. So what the solution was we just deleted the copy constructor. And when you do that, you get back the default copy constructor, which is, it's not explicitly listed there, but the default copy constructor looks like this, which is actually, usable in more instances than the other one. All right, but those two things are what the compiler recognizes as copy constructors. And that's kind of important because sometimes we want copy constructors to be called automatically for us. Sometimes we call them explicitly, right? We say like, we build an object and as a parameter, we pass in an instance of another object. That's an explicit call to a copy constructor. But other times we want to do things like if we're passing a parameter by value, well, we want a copy made. And so we want that to call our copy constructor, which is an implicit call, as we will see. A copy constructor is provided by default, however, performs a member-wise assignment. And even assignment, that's probably not, it's correct-ish, but it's a misleading word because it doesn't use the assignment operator. It uses the copy constructors of all the member variables, right? So if I have a date class with 3 ints, and I make a copy of that, then to copy the ints over, it calls their copy constructor, which is just a basic, that's just a basic mem copy. But our default copy constructor does what's called a shallow copy, right? Which is, it doesn't do anything other than that. It just calls all the copy constructors of all the members. And usually those are quite simple. And when you get down to the primitive level, it's just a mem copy. All right. Well, let's jump into some examples. So here we have a song class. We have a constructor and a destructor. The constructor has a bunch of default arguments. And we have an ID and a title and an artist. And the implementation, quite simple. So our constructor just assigns these to the member variables, and then we announce that, let's just put this, song constructor, just so it's not so, and then song destructor. And so we can make a song and then print a song, but then we're going to make a copy constructor. All right, so there we go. We made a song, Nirvana song. The song constructor is called. We printed out the song, there it is. And then we exited the function and then the destructor was called. So far, so good. That looks like, everything that we would expect to happen. Well, now I want to implement a copy constructor. So I'm going to implement this version without the const. We'll get to const later. And then we'll see how many times I can write song in a row. So there's my copy constructor implementation. And basically what I want to do is this sort of the simplest thing possible. ID equals song.id. Title equals song.title. And artist equals song.artist. Okay, and this is, so we're using the assignment operator here. And that's fine, like that's okay. Because generally speaking, the assignment operator does the same thing as the copy constructor does. So this is going to make a copy exactly the way we want. So our int will be just a byte for byte copy. The strings are a little more complicated because they probably have some, memory on the heap, but the string class handles all that stuff. And I know that's handled correctly. And then the final thing we're going to do is just say copy constructor. All right. So let's make a copy. We're going to start with an explicit call to the copy constructor. So we have our song S1, and then we're going to build a song S2, and we're going to pass S1 in as an argument. So explicit means that I explicitly provide the parameters to a constructor call. And this is how we do it when we declare a variable, and then I'll print them both out. So we made song one, we printed song one, we copied song one, and we see the copy constructor was indeed called. We printed out both songs, and they both look exactly the same, and then both songs got destroyed. And this is an explicit call, and I'm going to keep hammering that home because there is a sort of a big difference between explicit and implicit in terms of how it can be used. What questions so far? Okay. Let's look at another way to call a copy constructor. And this is an implicit call, but I'm going to declare a song S3, and I'm going to assign it S1 all in the same step. Now, I didn't explicitly call any constructors here, but for whatever reason, C++ will interpret that as I need to make a call to the copy constructor. Probably that's just the easiest thing to do in this situation. Yeah, well, yeah, I forgot to comment that out, but here's the implicit call to the copy constructor using this syntax, and we can see that the copy constructor does get called. It does make a copy of the song, and then those are both destroyed. There is a woo clap today, yes. We will get to it shortly, actually. Okay, so, well, that's interesting. I'm not sure why. This is probably some legacy reason, but the most often sort of implicit call to the copy constructor will be in a situation like this. So if I look at my pass by reference function, well, I'm passing a song by reference. So this will not be the one that I'm concerned with, but let's see what happens when I pass by reference. So I'm making a song, and then down here, I'm passing a song into a function. My pass by reference function just prints the song, and then I return. So there we go. And you can see that the copy constructor was not called at all. And the reason being, because I passed by reference. All right, so, well, what happens then if I decide I forget about passing by reference and I instead pass by value? Well, I could do something like this. All right, so I'm calling pass by value. Pass by value does the exact same thing, except here is my song, and there is no reference syntax. And when I print that out, so call pass by reference, everything works fine. When I call pass by value, the copy constructor is called. So I have a copy of that song in my function. I can still print it out. It prints out the same. When I exit the function, that song gets destroyed, right? So when I pass by value, I make copies of objects. When I pass by reference, I do not. And so that's why we generally prefer, especially for objects, for primitives, we don't care so much. But for objects, we want to pass by reference whenever possible, because it's going to save us a lot of this extra work, right? I have to make a copy, which may take a while, or, it's going to take a few fractions of a second, but in terms of CPU time, it might take a long time. And then we have to destroy that thing also. So that can be expensive. All right, questions? Yeah.
And you have like a object and one of its attributes, another object. Okay. Would it copy the reference or would it copy the value of that?
By default?
Yeah, with the
So if I had an array as a member variable, and then I just did an assignment? I mean, that's actually kind of a good question. I'd have to try that out. So, because arrays are different, because technically when I have a variable that is an array, that's a pointer. It doesn't look like a pointer and we don't use it like a pointer, but it is a pointer. And so if I just did a pointer assignment, that could be bad. I'll have to try it out, which, I don't know if we have time. Maybe we could try it out really quickly. If I did something like this, and then the copy constructor. So we did, yeah, title. Maybe this will give us an error now though. So I'm just going to get rid of that. It won't work. I'll just get rid of that one line that does this. That should be okay now. I don't know. Let's see what happens. Actually, let's do this. So it doesn't like that. Invalid array assignment. Okay, so I guess the syntax, you can't do that. So you'd have to do something more explicit. Probably like loop over it and copy from one to another or something. But yeah. So yeah, that's interesting. Good question. I wasn't sure what would happen, but it doesn't let us do this. For whatever reason, the assignment on an array is deleted. Cool. Other questions? Would we want to pass objects by value over reference in any circumstances? Yes. Off the top of my head, I can't think of any, but certainly for a return value, you often want to, and if you think of return values as similar to parameters, which they kind of are, they follow sort of the same set of rules up to a point. You often want to return by value. So that in that situation, you would want that implicit call to the copy constructor. We'll see why. Well, at some point, we'll see clues as to why as we go, and then at some point we'll be able to put it all together. Other questions? Okay. What was I doing then? Oh yeah, so pass by value. Yeah, it is possible, especially for like even if I know that my song is not a huge, takes up a lot of memory or whatever, then pass by value is sometimes valid. But if you are passing a object into a function and you're not sure, should I do pass by value or pass by reference? If you're not sure, then you should do pass by reference. If you are sure you need to do pass by value, then do pass by value, right? So that's sort of the rule of thumb. Let's try return by value. So my return by value function looks like this. I make a song. It's statically allocated, so it's a local variable, and I return it, but I'm returning it by value. And just to clean up our output a little bit, that will be the only thing that we do. All right, so well, the constructor gets called, we make this song, and then the destructor gets called, and nowhere is a copy being made. But technically, it should be, right? So what's happening here is, right, because if we look at logically what should happen is that I call this function, I put this stack frame on the stack, I allocate a song in that stack frame, I return that song by value, which means I should make a copy of that song and return it to the calling function. But the compiler the compiler looks at this and for some reason recognizes that, hey, I can get away without making a copy here. I can just make this song, but I'm going to do it in this memory location, right? So the compiler is doing a little bit of optimization. It's called, I think it's called, I don't know how to pronounce it. I've only ever seen it written, but it's called elision or something like that. Compiler elision. It just means the compiler recognizes that I don't need to make a copy here. I could just make room in the calling function. But this still is technically a place where you call the copy constructor because, and it's an implicit call, as we will see. But yeah, questions on that? Okay, so why do we care about explicit versus implicit? Well, we can do something like this. We can say, I can use the explicit keyword in my copy constructor, and then in my main function, I can, well, I only have return by value right now. But yeah, here I'm not allowed to use this. And it's saying the error is deceptive. It's saying it cannot convert it to an int because it's trying to, it says I can't use the copy constructor, but now we're here, it's trying to use this constructor and saying, well, if I can convert that song into an int, then I can supply it to the, as a parameter. Anyway, C++ doesn't always give the most useful error messages. But this is basically saying you're not allowed to do that anymore, right? So this is technically a call to the copy constructor, even though no call was made. When I put explicit here, I'm no longer allowed to return by value. Also, if I try to pass by value, now I need this song. Well, I'm no longer allowed to pass by value either, and I'm no longer allowed to do this. Where is that error? Let's get rid of some of this stuff so that I can see correctly. All right, there we go. So yeah, I'm no longer allowed to use this. So all these implicit calls now are no longer allowed, which is, you should sort of think very carefully if you want to do this because now I can no longer pass songs by value, but maybe that's what you want. All right, questions? All right, so on the subject of explicit keywords, let's look at something else here. Let's look at this. So here, danger. It's not just the copy constructor that gets called implicitly. Sometimes the constructor gets called implicitly, as in here. So I made a song, and this is an actual bug. Oh yeah, well. This is an actual thing that I did and took me a while to track down. All right, so I made this song by saying song S5 equals 5. Now, when I did this originally, I had meant to do like S1 or S5 or something like that. This was, anyway, I forget. I forget what the exact number was, but I just made a typo, right? Instead of just putting the S, I put a number. And then I kept getting this weird output, and I couldn't figure it out for the longest time. So yeah, this works. Why does this work? I'm assigning an int to a song. Well, the compiler, trying to be helpful, will say, well, can I take an int and convert it into a song? And it says, yeah, I can. I have a constructor here, and if I call the constructor with just an integer argument, then these two will have default arguments, and I can make my song that way, right? So the compiler will take this and actually make a song for you, supplying 6 as the first argument, which is, to me, that is bananas. Because that's, took me a surprisingly long time to find that. If I want to disable that, I can also add the explicit keyword here. And now it says, you're not allowed to do that. Which to me, I don't know when I would ever want to do this. It doesn't let you pass, well, I probably depends on the compiler, right? So this will not work, whereas it'll try to convert this int into a song in my pass by value. But you know, the older compiler versions may allow this. But whatever, it's just I don't know, man. To me, this is just asking for trouble. But questions? All right. So yeah, that's all copy constructors. So a conversion constructor is similar to a copy constructor, right? Basically, I have two similar classes. Maybe they have some parameter or some member variables in common, right? If I have a date time class that has a year, month, day, and then some time variables, and I have a date class that also has a year, month, day, then I can convert my date into a date time. And then either using this syntax, right, the explicit call, or again, I can use implicit calls with conversion constructors. Now, sometimes I manage to like fit conversion constructors into an assignment, and other times I don't. So I'm not sure if you'll actually work with conversion constructors, but you should still know how they work. Basically very similar to copy constructors, but with a few small differences. So I have my songs. Do I need these explicit? Let's get rid of those. I think those will cause trouble. I've added some getters here. We will see why in a moment. And then I have a video. So I don't know how big videos are today. I know they still exist, but it's, you know, once upon a time, you take a song and you put a little movie to it, like, you know, some, I don't know, whatever, some 5-minute artist's vision of the song, and then that was a video. And it was so popular, they had like entire channels dedicated to it. This was, you know, a long time ago, back in the 80s. I know they still have videos. I don't know how popular they are, but once upon a time, it was a huge deal. So in this case, maybe I want to take a song and I want to convert it to a video. And well, I'm going to do it kind of artificially here because, well, my video has a title and an artist, the same as my song, but then I'm going to add like a length variable. It's just whatever. It's just made up. This makes no sense in terms of my member variables, but just a way I'm going to convert a song into a video using a conversion constructor. All right. So when I write this conversion constructor, well, what I really want to do, right, I need to initialize title, artist, and length. So I could do something like length equals, well, I'll just give it a default value. And then I want to do artist equals s dot artist. And sorry, my brain is saying one thing and my hands are doing another. Title equals s dot title. So that's kind of what I want to do. But of course, I can't do that because these are private. So in my song constructor, I can do this because, of course, in C++, a instance of a class can see the private member variables of another instance of the same class. So this song can access the private members of old song in this case. But now these are two different classes, so I no longer have that, that privilege. So I'm going to use getters instead. There are other ways to solve this problem. As we will see, we can make these two classes friends. We'll see later when we get to friendship, but for now, this is good, right? Anytime you can solve a problem with a getter, that's a good day. That's a nice, simple solution that everybody will understand. All right. So we're going to start by making a song, and we're going to make a video. And the video, we're just going to use the regular constructor for now. I just want to verify that everything is working. Okay, so we have Pain of Infinity, and then we created a video, Everlong by the Foo Fighters, and then they both get destroyed. Okay, so both classes are working. Now I want to try to make a copy or a conversion of this song into a video. Right, so I'm going to make an explicit call to the conversion constructor. And here we go, creating video 2 from song 2. The conversion constructor is called. We print it out. It prints like a video, which is basically just 2 stars, whatever. And then they're both destroyed. All right, so that worked out exactly as we would think. Of course, like with the copy constructor, we have implicit calls. So I can declare a video and assign it a song in one step. And there we have the video conversion constructor being called again. We can do, as we did with the song, we could do pass by value. Now this is, if I look at this pass by value function, it takes a video, but the video is passed in by value. And I pass in a song instead. And so, and then in my pass by value, I believe I print it out. So video pass by value, I take the video, I print it out and return. There we go. The conversion constructor is called when I pass that song to a video. It gets converted into a video. I print out the video, then the video is destroyed, and then the song is destroyed at the end. All right. So again, this is all behavior you would expect from a copy constructor. The one last thing is return by value. So the compiler optimized this away when we did this with the copy constructor. But now return by value, it returns a video. It makes a song locally, returns it where it expects the return value to be a video. And you can see here, well, actually, the conversion constructor is called here. So we make a song, the constructor is called, convert it to a video as we're returning it, the song gets destroyed. The video gets destroyed shortly thereafter because, well, I didn't do anything with the return value. So it's just a temporary variable that gets deleted as soon as we're done. But yeah, here, there is no like copy elision going on. There is no optimization. This is just making a copy. Yeah, I think that's it. Questions? And then just to, you know, for completion, explicit, if I add the explicit keyword, and then I try to compile this, we're going to get a bunch of errors. So we have return by value, so that should definitely give an error. Yeah, so this could not convert from a song to a video. I'm not sure if that'll work and get rid of that. Will we get a warning? Yeah, just a warning. All right. So yeah, this is no longer allowed. This is no longer allowed. This is also an implicit call. No, it isn't. Save. Right, so I'm not allowed to convert a song to a video implicitly. This pass by value is no longer allowed. Right, cannot convert from song to video, but I am still allowed to make an explicit call to the conversion constructor as here. So I still get the warning, but what is this P5? I still get the warning, but for no return value, but the conversion is permitted. All right, so conversion constructor, copy constructor, and the explicit keyword. Questions? All right. 7:15. I believe that takes us to a woo clap. We are A section. Okay. So I had thought for whatever I thought, because if I don't exit this, then I come back to it later, it says it's still in progress. So I was under the impression that as long as it was open, you guys could go back and like answer questions. Then I realized as soon as I progress, you're no longer allowed to answer those questions. So I'm going to slow down a little bit on the woo claps, because I was saying to people, like, just go back, and if you didn't answer, then just click anything. But apparently you can't do that. And I think when I compile the woo claps, it goes question by question. So I'm going to try to like update my marking script to say, like, if you participated on any day, any question, then you get your participation mark for that day. But also I'm going to go slower. So like, please try to answer every question, but you know, try to give a quality answer, or at least think about it a little bit first. 74. 44 online. You mean right now? We haven't started yet, so let's try. Yeah. All right. So which of these statements would call the default constructor of the student class? You can select more than one. And this is assuming there is one, meaning assuming that student has a default constructor. So first of all, what is a default constructor? And second of all, which of these would call it? So yeah, I guess the first question to answer is, what is a default constructor? Well, in this context, what we mean is a no argument constructor, right? So which of these would call the no argument constructor of the student class, whether that is a regular constructor with default arguments or a constructor with no arguments? Right, let's see what people have answered, and then let's talk about it. So again, right, so the definition of default constructor is a no argument constructor. This constructor, I am actually passing in arguments, so it would not be number one. Here, I am making a student with no arguments, so this will call the default constructor. Here, we didn't talk too much about pointers, but I'm hoping, you know, just to get you thinking about the subject. Here I'm actually declaring a pointer to a student class, but I didn't actually make a student class, right? So no student class is constructed here. This is just a pointer. Down here, I have an array of 5 students statically allocated. So this would have made an array with 5 students, and the default constructor would have been called on each of them. And then down here, again, it's a statically allocated array, but each member of the array is a pointer. So there's no students being made here. So the answer to both of these is, the answer to this question is both 2 and 4. This is not the first woo clap we've had, no. But don't worry, right? As long as I think I'm saying 80%. So that's, for now, if you do at least 80%, you get 100% of your bonus mark, or mark. Sorry, it's not a bonus in this class. Right, but I'm gonna sort of take into consideration that you can actually miss answering. If you're thinking about a question and I go through too fast, you might miss answering it. So There may be some adjustments made to that. So I wouldn't worry too much about missing a 1 or 2. All right, questions on this? Which of these code snippets would call the copy constructor of the student class? Again, you know, select as many as you think are correct. Also, just a reminder, don't sign in with your name, eh? Either using the single sign-on from Carlton or just type your name, hopefully as it appears in Brightspace, but you know, even if it's close, I'll work it out. So the copy constructor, well, let's see what people are saying. Ooh, spread out here. Well, this one we talked about, right? This is, I believe it's called initializer syntax, but I declare my student Amy and assign Amy or assign Stu to Amy in the same statement. It's an implicit call to the copy constructor. So yes, number one would be correct. What happened? Yeah, so number 1 is okay. Number 2 is, well, this is an explicit call to the copy constructor. So yes, number 2, it would be called. Number 3, it's a little tricky because we are still making a copy of Stu. We're copying Stu to Amy, but technically this will use the assignment operator and not the copy constructor, which we haven't really talked about, although I probably did mention it in passing. So yeah, this is actually a different function from the one that is called up here, even though they are supposed to do the same thing. Down here, we are passing a student by value, which means this will call the copy constructor. And down here, we are passing a student by reference, which means this will not call the copy constructor. All right, so these 3 are correct. The other 2, not so much, although this one is a little tricky. It does this, it should do the same thing, but technically they are 2 different functions, which means that you can do different things in them if you like, right? So, but yeah, this is, I mean, a lot of the questions I ask here are not meant to be like, they're meant to help you think about things and like introduce you to ideas that we're going to solve later. So we're actually going to write assignment operators at some point. True or false, the following code will compile and run. Somebody pointed out that I think in maybe in the latest version of the compiler, the fact that I'm missing a return statement here, this means this would not compile. So that's perfectly valid. But let's pretend that the return statement will not cause a compilation error. I think it depends on what version of the GNU compiler you're using. Because in the past, this has just given me warnings. Or maybe I'm totally remembering wrong. But yeah, will this compile and run, assuming that the return value won't matter? And what is the issue? So the issue we're considering is, well, I need a no argument constructor for this array, right? I'm going to make 5 student objects, and a constructor needs to be called on each of them. Now I don't have any constructors defined here, right? What have people said? A lot of trues. I don't have any constructors defined here, which means that I actually get a default constructor for free. I can make instances of a student, so this will work. As soon as I add a constructor with any amount of arguments, the one that you get for free gets deleted. But for now, I do get one. So this, the answer here is true. Questions? All right. Following piece of code. Yeah, so what's this going to print? I have a no argument constructor and I have a destructor as well. And it's multiple choice. See, I expected an email first thing about the exam and I didn't get it. It's not a good sign. All right. Well, what happens when I make this array? Well, this is a statically allocated array. It's going to call this constructor twice in a row. So I am going to get in CTOR twice. When I exit this main function, well, we haven't really talked about what happens to statically allocated arrays, but they get destroyed. They have a destructor. But what the destructor does is it calls the destructor on every member, right? And so I say that, you know, even if it's an array of ints, technically ints have a destructor. It doesn't really do anything, but that is to say the destructor will get called on both of those students. So the actual answer is number 2. First, 2 of them will get constructed, and then 2 of them will get destroyed. That is the, most of you got that. That's great. Questions? All right, so that's it. I guess that's, I might as well exit. If you answered, hopefully you answered all of them. If you only answered a couple, I will, like I said, I'll see if I can adjust my marking script a little bit so that if you miss a couple questions, it doesn't affect your participation grade. All right, so that is basically everything you ever needed to know about statically allocated memory. You will get a deeper understanding as we go, but we're going to move now from statically allocated memory to dynamically allocated memory. For assignment 2, right? Basically, we're going to, in assignment 1, we put everything on the stack. In assignment 2, we're going to put all these big data structures, as many as we can, on the heap. Right? That's where they should be, because you know,
Hi, Dr. Hammond.
you can't actually overflow the stack. You don't want to overflow the heap. Midterm 1 is actually a week from today. So this is not, this is actually a good time to learn about it. Because yeah, the only thing I still am not 100% sure if it'll be on paper or if it'll be programming. But there will be a practice exam released today or tomorrow, depending on, right, if we can't get this COMAS stuff straightened out, it'll just be on paper. All right. Memory management. So we're going to review some memory stuff. I skip over, probably go pretty quickly here because this is a sort of a review, but when we're allocating variables, we're really concerned with the stack and the heap, a little bit the data segment. So we're going to talk a little bit about the memory model. We're going to talk about pointers, and then we're going to look at you know, how we allocate memory and how we do it responsibly. And then we will, right, look at a whole bunch of different array types, basically based on how we divide it up into memory. So recall when we run an executable, we get a bunch of sections of memory. Well, basically we get a whole chunk of memory here that is divided into different segments. So we get our data segment here, we get our code segment here, and we get our stack, and our stack kind of grows in this direction. And if we overflow, well, then the program crashes. And then sort of way off over here is the heap. This is basically, I ask the operating system, like, hey, can I have some more memory? And the operating system, for the most part, is going to give it to me. So yeah, code segment is our program instructions, data segment, global variables, static variables, and string literals. So static variables we will see a little bit later. Function call stack and the heap. Again, these are where most of our variables are going to be. So local variables. and function parameters and other sort of metadata, like, when this function is done, which piece of code should I return to? And then there is the heap as part of the data segment. So that, again, I think that's a little outdated, this idea that it is part of the, again, it depends on how the compiler implements it, but I don't think that's a good way to think about it anymore. But it stores all dynamically allocated memory. So all stuff we ask for and get back. All right, so hopefully you guys know what a stack is, right? So it's just a last in, first out data structure. Think of a stack of plates. I get a clean plate, I put it on the top. When I want a clean plate, I take that plate off. So the last thing I put on top is the first thing that I take off, right? And if I add something that is known as pushing an item, and if I remove something that is known as popping an item, and so a function call stack is just a stack of stack frames, right? So that's basically how I know how to, proceed through my function calls. Yeah, so if I guess just for completeness sake, I'm sorry if this, some of this might get boring for some of you, but I make a call to the main function and I allocate, two local variables, X and Y. Well, those will go on my function call stack. And then from main, I will call foo, and maybe I'll pass in X and Y as arguments. And these are passed by value, so I will make copies of them. And then again, I will have something that, those will get added. And meanwhile, I have my stack pointer points to the, where the stack ends, essentially. And then maybe I allocate a new member variable here, Z. So I guess this should be pointing over here, and the Z variable would be stored there. And then I call absolute value, maybe I pass it Z. Well, that value gets copied into X. And so my function call stack looks something like this. When I return from this function, well, basically I just move the stack pointer back, and this gets the destructor called on it. And then I return from foo. Well, again, that stack frame gets popped off, so I go back to this stack pointer, and the destructor is called on all of these. And then I return from main, and those get destroyed, and then I'm done. So that's what our function call stack looks like. Now our heap is slightly different. It's dynamic allocation. So basically, anytime I use the new keyword, the nice thing is it sticks around until I call delete, right? So I don't have to worry about whether I pop off a stack frame, although I do have to worry about where the pointer is. Right, so now let's say in a function, I say, well, give me a new student. Well, on my stack frame now, I will have a pointer variable. And then that pointer variable will point to the memory returned by the call to new, which should be, enough space for a student, right? So I say new student, the compiler comes back with enough memory for me to store my student, and the address, which I store on the stack, which means that the only way I can access this memory is through this pointer. So I have to take very good care of it, right? If I lose the pointer, like I pop off a stack frame and it gets deleted, then I lose this reference, and now that's a memory leak, right? So I do have to be careful. I could also have a pointer, I suppose, in the data segment. And then as a global variable, right? That's, of course, perfectly valid. But for the most part, they're going to be on the stack, and we have to take very good care of them. So statically allocated memory reserved in the context of the variable. We've seen a lot of, local variables in a function call. And so when that function returns, the stack frame's popped off, the context is destroyed, which means the destructor gets called on that variable. On the other hand, dynamically allocated memory sticks around until we call delete on it, right? And I can put whatever I want really on the heap. So I can see here, I put a primitive, an int, or a student. And then I get back a memory address for either of those. So a pointer is a variable that stores a memory address. We can use it not just to point to stuff on the heap, we could point it to whatever. They do have a type though, and you know, they are also, basically when I pass by reference, I'm passing a pointer around. I'm just hiding the syntax. Syntax is kind of ugly sometimes. All right, so like all variables, pointers have a name, they have a type, they have a value, and they have their own location in memory. So let's jump to an example. So I'm just going to sort of illustrate what happens here if I have these three variables. Now, these are, you can imagine that these are memory locations, right? They're kind of short for memory locations, but they're hexadecimal. And so if I define, let's say, a char C, well, it has a name C, it has a type char. The value is whatever the hexadecimal value for H is. We could put that in. And it has a location of A8. All right, and then I can make an int called I with a value 42. So it has a name I as a type int, the value 42, and it is in location A9. And then finally, I can make a pointer to a char. So the name is char C pointer. It has a type of char star. Its value, well, I don't have a value here, but let's say that I pointed it to C. So I would do something like C pointer equals address of C. So the ampersand. That's my, I don't know if it's a great ampersand or not, but that's the best I can do. And so in this case, it would give it a value of the memory location that C is located in, which is A8. And then its location is AA. All right. So then when I do something like if I want to print that out, right? So I send C pointer to the standard output. I should get the value that this variable has, which is A8. Now in reality, I don't actually get that, as we'll see. But for teaching purposes, we will say that we get A8. If I want the value that it's pointing to, well, it's actually pointing to the C variable. If I dereference it, well, that says, well, look at this value and then jump to that address. Well, that's here. And then grab me the value you find there. So that's an H. So if I dereference it, then I should print out an H. That happens with every pointer but character, ironically, because characters are kind of special, as we'll see, but let's jump into this example. Okay, so we have basically what we had, but we have an I pointer here instead of a C pointer. Let's make a... Yeah, let's do the address of C. All right, so this is, I assigned it a null pointer. So null pointer can be assigned to any pointer. And it's a good idea to, if I do not actually assign it a value right away, it's a good idea to assign it null pointer. This will catch a lot of errors for you. But otherwise, we have the same setup as we had before. Well, let's just take a look at the size of these things in bytes. Whoops. All right, so my char has a size of 1 byte, my int has a size of 4 bytes, my pointer to an int has a size of 8 bytes, and my pointer to a char has a size of 8 bytes. And what that means is that we often pass by reference using pointers or references. And well, for primitives, we don't really need to do that. If we can get away with pass by value, then it's fine to pass primitives by value. Okay, because they're often not even as big as their pointer. On the other hand, let's say I have a class called fake here, and I have an array of 10 ints and a char. Well, if I look at the size of fake compared to the size of its pointer, you can see that the pointer has 8 bytes and the fake class has 44. So if I'm passing that by value, I have to copy 44 bytes. If I'm passing it by pointer, I only have to copy 8 bytes, right? So that's going to save us a lot of time passing by reference. It is actually, we can look at the size of a reference too, but we have to do it in a roundabout way because size of doesn't work correctly with references. It'll just give me back 44. But if I wrap it in a struct, then it can figure out the size of this struct, and the size of the struct will be exactly the size of this reference, which is in this case 8. So pointers and references are both 8 bytes. The thing that they're pointing to might be a lot bigger. So pass by reference using either pointers or references is the preferred way to pass these objects. Questions? Okay. Well, so my I pointer, if I want to point it at, I could, make a call to new. That's perfectly valid. But I mean, if I just want to point it to the address of an existing variable, I can. The ampersand is the address of operator. So in this case, I pointer will point to I. And now I can access the variable I either using the pointer or using the variable itself. All right, so I can do things like, well, first we'll look at the address of I and the address of I pointer, and then we'll look at the values being held in each of those. And so let's focus on the last 4 digits here. So my address of I, which is an int, is 1194. The address of I pointer is 1198. So it's right next to it in memory. The value of I is 42. The value of I pointer, well, it's actually the address ending in 1194. So it's actually the same address as this, as I, right? Which is exactly what we would expect, but there kind of we have proof. And then we can do things, well, if I want to print out the value at I can use I directly. Or I can dereference the pointer, right? And that will print out 42 in both cases. So here I is 42, and I dereference I pointer, I also get 42. All right. Finally, right? So basically a pointer, when I dereference it, it behaves as the thing it's pointing to. So when I dereference I pointer, I get back an int. I can assign an int a value, in this case 99, and then I can print out both I and I pointer. And they both output 99 in this case, right? Because again, it's the same variable. All right, so that's basically pointers. Questions on any of that stuff? All right, let's look at some sort of fun, a little bit of, maybe not fun, but interesting. So I can do things like, well, my pointer has an address, so I can make a double pointer. Now a double pointer is a pointer to a pointer, so I can assign it a value of an address. And your compiler is going to make sure that this is the correct type, right? So I can't accidentally give it the address of a double pointer, let's say. Well, I can take my double pointer, and if I look at the address of my double pointer, well, I need a triple pointer to point to that, so I can make a triple pointer and point it to my double pointer. And then I can make a quadruple pointer and assign that the address of my triple pointer. And the compiler will type check all of this, and that'll work. And then I can take my quadruple pointer and I can dereference it 4 times, through my triple, my double, and my single pointer, and finally to I. And that should print out 99. So there we go. Our quadruple pointer dereferenced 4 times gives us 99. Now, why you would want to do that, I'm not sure. The C++ specification last time I checked said that this is valid up to 12. So up to 12, the compiler will check. You can dereference, you can have a 12 pointer. We will not use anything more than a double pointer in this class. But yeah, you can use more. Memory on the stack, always sequential. Usually, I would say yes. I would say it'd be very rare to find it not sequential, but of course, C++ again is just a specification. So a compiler, they can do whatever they like as long as it meets the specification, right? So it's not really something that is always the same between compilers. Although I would say for the most part, they probably do that. All right. Yeah, of course, if you use void pointers, right, a void pointer has no type, so you can go as deep as you like. You can dereference 100 times if you like. One other thing, I have this character pointer. This is a puzzle, let's say. Let's do this. Going to get rid of all that. So I just have this this character pointer. I'm going to and then I'm going to do the same thing with the I pointer. I'm actually going to give this the address of I here. All right, so we did this earlier. We saw that I pointer gave us a memory location. C pointer gives us something different. So this is, this is what we would expect. We've assigned the memory location for the variable I to I pointer. Here we've assigned the variable of the memory location, or the address of the variable C to C pointer. But when we print it out, we get this. So what happened? This has to do with C and how C deals with strings. Yeah. What's that? Sorry. That is correct. But that's not. I should still get the address of that literal technically. But yeah, you are right. It does point to a string literal, sort of character literal, I guess. So when we print a string in C, what are we doing? What is a string in C? Strings in C are awful, aren't they? Yeah. Yeah, it's just an array of characters, and the variable that contains that string is a pointer. So when a C string is just a pointer to a memory location, and when I try and print it, it will just start reading characters until it reaches a terminator, right? So here, luckily enough, there was a terminator. Well, I don't know. There might be some invisible characters there. But somewhere it reached a terminator. Otherwise, I would have just kept printing and printing and printing. But there was an H at the beginning. So it did print that. So this is just legacy behavior from C, where if I have a pointer to a character, I could technically, that could be pointing to a C string somewhere in memory. If I want to actually see the memory address, I can cast it to a void pointer, and then it'll print out just fine. So there we can see the address that is pointed to by my C pointer. So yeah, that's just, anyway, nothing really to do, or not much to do with our current topic, but sort of maybe fun facts, let's say. But questions? All right, 5 minutes, huh? All right, so yeah. A pointer variable declaration has 3 components, right? It has the type of data being pointed to, the same as any good variable, the star symbol to indicate that it is a pointer, and the variable name. And actually, I've been writing pointers a certain way. I've been doing this. The actual recommended way, I think, is this. Both of those will work, however. What's the difference? Well, if I do well, what are these now? Well, X is a pointer to an int, but Y is an int. It's not a pointer, right? So if I wanted to declare X and Y as pointers, I would do this. All right, so this is good syntax for declaring two pointers, which is why, I tend to put it, because in my mental model, like this makes more sense to me. But you'll see it written this way a lot, and this is probably like syntactically maybe a better representation because it reminds you that, hey, if I make multiple declarations, I have to sort of, the type is int, and this means pointer, but I have to, the pointer goes with every single variable. All right. So pointers can receive, well, we've seen, I can take a pointer and I could point it to a memory address of a statically allocated variable, or something we haven't seen as much of, I can make a call to new, and that returns a pointer, and then I could store that in a pointer. The star symbol is the dereferencing operator. So in some sense, I'm saying like follow the pointer, grab what you find, and return it to me. And then if that's a variable, I can treat it like a variable. Null pointer exception, we haven't seen that, but if I had a pointer, right, that let's say in this case, this was originally null pointer. And the nice thing about it, here I tried to print it. Oh, yeah, it gives me a 0 here. If I tried to dereference it and print it, I get a seg fault, which is good. Like that's what I prefer to have happen. Because I could also do something like this, right? I can forget to assign it a value, and then maybe it'll crash, but maybe it won't. Maybe it'll just give me some garbage information and still keep running, and now I have a bug in my program that's hard to find, right? So yeah, always a good idea to assign it a null pointer if I'm not using it, and check for null pointers, right, before I dereference it. Be careful of these symbols. They have multiple roles, right? So when I declare a variable, this indicates a pointer. This indicates a reference. Anywhere else where I'm involved with variables, this is dereferencing, and this is the address of. But of course, this is also multiplication in math, and this is, well, I don't remember exactly what it does, but it has also multiple roles. So you, like everything in C++, you have to pay close attention to the context. All right. So next class, we are going to look at this. Well, this is something we've seen before. We just have a little program that uses some output parameters where we pass them by reference. And so we're going to switch these to pass by reference using pointers and just look at the difference in syntax. And so it'll look different to us. To the compiler, it'll look exactly the same. But yeah, we'll stop there today. I really hope to have information about the test today. I'll let you know what's happening regardless. But yeah, get your assignment and your tutorial 2 done. And I have office hours in half an hour if you need some help. Otherwise, have a good weekend, and I'll see you next week. Yeah, we can do a review. Yeah. Again, I'm sort of, what exactly that'll look like, I'm not sure. I have to figure out what the test looks like first. Hey.
Sir, is there a question about how the loop maps work?
Yep.
So how do you tell like if we're correctly, because like I've been training today, and like is it an issue of like I check my SAS, but it's just signed in as anonymous?
Yeah, you shouldn't have signed in as anonymous.
Shouldn't have. I just like typed the code into the like I switched up lookup on my phone. I did it onto the website. So I'm just like I don't know if like I registered for like the other one.
Oh, you can, I mean, whatever, you register for a different class?
No, like I like no like because like I